Lesson 84. Today we are going to do more of your favorite proofs using trig functions. And then we're also going to sketch some more sine and cosine graphs. A little bit more complicated stuff today. Okay? Do remember with these, you cannot cross the equal sign. Okay? With this one, I don't even know if I would be tempted to, but just remember that you're not allowed to do that. Alright, so if we look at this one, cosine of x minus cosine x times sine squared x equals cosine cubed x. Alright, well the first thing that I see is I can factor cosine of x out here. So that's where I would start. And then we've got 1 minus sine squared x, and that still equals our cosine cubed x here. Alright, now with this one here, 1 minus sine squared x, okay, what that one looks like to me is we've got sine squared x plus cosine squared x equals 1. Okay, I can subtract this sine squared x over to get cosine squared x equals 1 minus sine squared of x. And then because we have this 1 minus sine squared of x, that equals our cosine squared x. So cosine of x times cosine squared x equals cosine cubed x, and when we multiply these two together, there is our cosine cubed of x. Alright, and obviously the right side isn't going to change there. Alright, next one. Now this one I would get tempted to move it over. Alright, now with this one there are a bunch of different ways to do this. So I might do it one way and you might see a different way of doing it. It's okay, they can both be correct here. Alright, now, what I'm going to do is, because we have a fraction here, there's two ways of doing this. We could get common denominators for both, okay, and then kind of simplify it down from there. But what I see right here is I see the difference of two squares. So I'm going to factor this down here. So this would be secant squared x minus tangent squared x times secant squared x plus tangent squared x. And remember, that's all over secant squared x plus tangent squared x. And then that whole thing is plus tangent squared x, and we're trying to get that to equal secant squared x. Alright, now from here, this is all in parentheses, so this bottom would cancel out with this top. So we would have secant squared x minus tangent squared x plus tangent squared x equals secant squared x. These tangents cancel. We would have secant squared x equals secant squared x. And there's our answer there. Alright, now that might not be the easiest way to do it. It's just the first thing that I saw to try and simplify this down right away, especially to get rid of that fraction almost immediately. Alright, next one. Cosecant squared x minus 1 over tangent of x equals cotangent cubed x. Well, what we have is we have cotangent squared x plus 1 equals cosecant squared x. Now if we move this 1 over, we would end up with cotangent squared x equals cosecant squared x minus 1, and then this top could be replaced with cotangent squared x. And then if we wanted to break this apart just to see it better, remember this tangent's on the bottom. It's kind of like taking cotangent squared x times 1 over tangent, and that still equals this cotangent cubed. Well, 1 over tangent, we know, is the same as cotangent. And then cotangent squared times cotangent is cotangent cubed x equals cotangent cubed x. Alright, so there's our answer for that one. Alright, next one. Sketch the graph of y equals negative 10 plus 2 sine of 3 times x minus 45. Alright, so first thing that I would start with here is by making that a negative 10. Then we know, because it's being shifted down 10, we know that it's going to go up 2 and down 2. So this would be a negative 8 and a negative 12. Alright, and then I am going to deal with this 3 first before I shift it. So this 3 tells me I'm going to have 3 waves between 0 and 360. So each wave is going to be 360 divided by 3 would be 120. So each wave is 120 degrees. Alright, and because it's sine, we're going to start at 0. Halfway in between, we're going to be back at 0, so that would be a 60. Halfway in between those would be at the top, and then at the bottom, and then we just follow that pattern. Alright, and once we have all those points, then we can draw in that wave. Okay, but that is just the negative 10 plus 2 sine of 3x. We have to still shift it 45 degrees, and we're going to shift all of those points to the right. So this point here has to come to the right 45 degrees. Okay, 45. So every single one of these is going to go over a block and a half here. Alright, so what we know is we know this part here. Okay, over here it's not going to get all the way down to negative 12 by the time you get to 360, so we can just put an arrow going that way. Over here, remember each wave is 120 degrees. Okay, so this one here is halfway in between 120 and 150, so 135. It would bottom out 120 degrees before that, which would be right there. So then we would come down and then start to bounce back up. So our blue line is our answer here. Alright, our next one, same concept. We do have radians thrown in here, so if you want to, you could switch that into degrees. So we're going to multiply by 180 over pi. Those go away. Looks like we're shifting it 120 degrees here. Okay, so first thing, deal with the negative 2. So we've got a negative 2 there. Alright, and then amplitude is 4. So up 4 would be at 2 and negative 6. And then our wavelength, we've got 2 waves. So one wave, remember it's cosines, we're starting at the top here. One wave is going to end at 180, next wave at 360. Halfway in between these two, it's going to be at this bottom point. Same thing over here. And then halfway in between those is where it's going to cross the x-axis. Alright, so we draw in these graphs. And there's our wave, but we haven't shifted it 120 degrees yet. Alright, and this one is going to be a positive 120, so we got to do the opposite, which would be negative 120. So all 3 of these would fall off. This is the first one that would stay on. This one would be at 135, shift it, 120 would be there. 180 shifted would be here. This one would be there, and So these are the ones that we know for sure based on our previous points. Okay, now if we look, each point where it crosses the x-axis is 3 blocks here. Okay, so if we count this one over, 1, 2, 3 blocks, that's where it's going to cross next. 1, 2, the third one is going to be over here, it's going to be off the graph, but it's good to know where that's at. Where it tops out or bottoms out is every 6 blocks. So this one would need to bottom out. 1, 2, 3, 4, 5, 6. There would be our 6th block. Alright, so we can come down and start to come back up. We're just not going to get all the way back up to the x-axis because that would fall off. We found that earlier. This one over here would start to come down. It would get down to its negative point kind of off the graph, so we don't need to put that one down. Alright, so there is lesson 84. Any questions? Let me know.